Hi everybody. So today we talk about Refuge, which you can see some code on the website right now. But the platform will be released next week on Wednesday, normally. So I'm Benoît C on Twitter. I'm web craftsman since 1995. Yes, doing websites at this period. Did my first company approximately at the same time in the web, and since I'm doing webs in different languages, and since 2008 mostly in Erlang and Python. I'm an Apache CouchDB developer, and I'm also doing some stuff in Python like most today. I won't talk about Python today, but I'm the manager or author of JUnicorn, which is the main web server today in Python world. My new baby, Circus, which is process monitoring, a la daemon tools, etc. That is starting to be used. And a lot of CouchDB related codes in Python. So what's Refuge? With our new logo that is designed by a member of the community. So Refuge really started in August during the Chaos Computer Camp. At this period, I was speaking Refuge as a decentralized data platforms still at this period, but for sensors data, so you can you would be able to have data coming from moisture sensors, light sensors, etc. And we started to hack it during the Chaos Computer Camp using a Chiva plugs and moisture sensors. The first try was having multiple sensors around with 2 Chiva plugs, connecting between themselves using CouchDB, and getting data in real time and displaying them with using Couch apps. So you can see there is a nice video from this hack, and it was actually working after 2 days of work. So, but big data. I know we are talking about big data, but do we all really need it? Do we all really need big data? Do you really have 1 petabyte that you really need accessible right now in your data center? Do you really need 1 petabyte of useful data today? A lot of people speak about distributing data, sharding data, but most of the sharding is in data centers. So every data is closed in data centers. I would say that big data centers aren't a solution for a lot of reasons. I was speaking in Warsaw last year during the Open Data Camp with the DataCov guys and European data center guys, and they were saying that they started to think how they could make the data more smaller, so they can distribute the data near the publishers rather than having them in a big data centers that expand, and explode. Can explode for multiple reasons. Floodings. We saw the Japan case with these big floodings that could happen in a lot of countries. You could also have a tornado. I was reading last week in Wired about the US government starting a new data center in Texas to monitor all the data around. We are speaking about petabytes of data. We are speaking about 900 square meters of data centers, big data centers. But they forget mostly the physics. And this is security too. Put something on 1 point, and you will have enemy that will be able to kill it. And they also forget the base, why they created DARPA, why they created internet, mostly to distribute the dangers of the data around. So today they are putting data in some data centers around in Texas. And there is 6 or 7 data centers in US, rather than expanding data around. and make it small so they can't be splits, cuts. And a big data center is expensive. I think big clusters is expensive. 1 year ago, I was about to launch new companies using Cloud and Big Cache. I did a lot of codes around that. I ported some geocache stuff to distribute spatial data centers. But I wanted to start without external financing. It was quite impossible to offer a good service. I mean, by good service, something that you won't be able to lose your data at any times. You will have only 1% of inactivities in your data centers. To have that, you have to spend a lot of money to start. And it wasn't really good for me. Also, big data centers, you can put data in bunkers, like Funin bunkers in Sweden, where WikiLeaks puts their data recently. But this is really beautiful. You can see the photo inside, outside. This is really beautiful place. But sometimes data center could also be that. This is actually the data center where is OpenBSD hosted in TO basement. So it could crash at any time. So definitely, big data centers are not really a solution. And again, do you really need to centralize this data storage? Publishers are everywhere. I have some customers that are working with a lot of companies around. Companies are collecting data before sending them to the big data centers and waiting the response then from the big data centers. Rather than centralize the data centers, why not just keep the data where they are published and make it possible to query them in real time, decentralized. This is what we will be trying to do in Refuge. Also, there is a big browser around. You want to put your data in clouds. OK, that's fine. So you have a lot of clouds. With some problems, WikiLeaks against that add their data in Amazon. Amazon just cut their data services. They weren't be able to store their data in the cloud, even if in the cloud guidelines they are saying they are independent, etc., etc., etc. So you should be able to keep the privacy in your data. But at the same time, be efficient. You need the real-time queries. So this is what is about the Refuge projects. To buy the decentralized data platforms, open source, so everyone can use it. So everyone, even if I stop to use it or to work on it, people can still work on it. Based on Apache CouchDB, Erlang powered, I will explain why. Multi-platform. By multi-platform, I mean able to work on your big servers, but also to work on iOS, to work on Android, to work on Chiva plugs, to work on any mesh machine that you want to buy, to build. What I mean by data platforms, something where you are able to collect data and store data, okay, to query the data in real time too, to render the data, to transform the data, which is what, if you are using CouchDB, we call today Couch apps, but maybe better than what we have in Couch apps today. And everything we can do with your big data center today, but decentralized. Why Apache CouchDB? Because I know it. That's the first reason. Because this is also a robust data platform. There's pretty good battery, even if it's a little slow. I never lost data with CouchDB, where I lost some data with some other database. Easily hackable. CouchDB is today 15,000 Erlang codes, mostly. So anyone can read it, take part, work on it. This is really easy. And even if it lacks some documentation in the code, you can still read it, even if it's Erlang's. because of the replication, the chance feeds, and because of the couch apps. About the replication, so I'm used to present that about the replication. The replication in CouchDB is incremental, which means you don't replicate all the data every time. You just replicate the new data you created. This is a master-master replication, so it means that you can replicate from one node to the other nodes, from one nodes to multiple nodes. You can replicate between one node to the other both ways in the same times, with 3 nodes, whatever. You can increase the number of nodes, increase it again, play what you want. There are some people that were playing with that in Japan, and they were going to 45 nodes in the same time replicated, without not so much complex. Replication in a nutshell, everything is based today on the chance feeds. The chance feeds CouchDB allows you to get all the change you made in the database, created a doc, deleted the docs, updated the docs, etc. And in the replication, you collect a group of document and revision ID at a time in the source database, and then send them to the target database. When you get it, it takes a new item, new document created, and then get each revision of documents from the source database and getting it back. And then this is replication. If you want to see all the protocol in details, you can go on dataprotocols.org, where it's fully described with the algorithms used. Why Erlangs? Well, most of the code of CouchDB is in Erlangs, little in JavaScript. You can properly ditch it if you want. Because this is a functional language, I quite like functional language. This is adapted to the products. We are building a network, and Erlangs was at the origin created to make a network platform. So Erlangs is pretty adapted to the language. So we started to build Refuge projects. The Refuge project started to really work since 4 months. And the first thing we had to do is to, one, repackage CouchDB and fork it somehow to improve some parts. Because the first things, when you want to put something in the cloud, you have to deploy it. And to deploy it, it should be easy to make it. You don't want to have to fight with the dependency on your systems. You can use Chief or Puppets or whatever, but it's really difficult to deploy a product when you have a lot of dependencies and you can't manage it. So I wanted to simplify the way CouchDB was distributed by building an Erlang release with Rebar, hopefully. I wanted to make CouchDB more hackable so I can remove the parts I don't want, and to improve the other parts that I think they are currently lacking in CouchDB. How today in CouchDB is packaged is based on auto tools and other new stuff that you don't really need it. You can just use Makefile if you want. The big problem today in CouchDB, so in CouchDB you have 2 big dependencies. This is issue for the collation and SpiderMonkey for the JavaScript engine. So SpiderMonkey is very difficult to embed in your code because mostly of the policy of Mozilla until recently. They didn't make a release of SpiderMonkey during 3 years. The last release was in 2008, and it was 1.7. During that, they have made a lot of enhancements in their codes, and every distribution started to package them using some part of the trunk, some part of Xel Runner in Firefox, etc., etc. So it was really hard to manage in CouchDB, and we had to fight with that. CouchDB by itself is not really embeddable because this is mostly built built as a full product, like a MySQL things. You send a database products that you will use in your client's application. And CouchDB doesn't provide Erlang stories, actually. You have to install CouchDB with an Erlang install by your systems and other dependency on the system. You can't just take the generated code from your CouchDB and put it on another platform. So we started to rework CouchDB packagings. We started to rework it with Rebar. And it mostly works today, but we had to fight with some difficulties in Rebar because this is young mostly. First, in CouchDB, so we are using NIFs and drivers to speak with the C code. And Rebar is not really good at that. There is part env that works and part source that works, but mostly if you have integrated the C codes in your Erlang codes. Like if you take Erlang.js from Basho, which was the first thing really to use C code on Erlangs, they took SpiderMonkey code, make an archive on that, and put in the Erlang code. So easy, but it makes big codes. And not so easy because when you want to put it on Linux, FreeBSD, macOS 10, Windows, etc., you have to provide patches. And Rebar today don't provide any framework to patch your C code easily. Other things that you can do today with CMake or AutoTools is to test if some shared library is installed on the system. You can't do it today in Rebar. What is really missing in Rebar, in fact, is a way to say, I want to compile this code, and if it returns false when I executed it, give me another way, use this path, or etc. What does AutoTools, in fact? There is also the problem on Windows. Rebar should be more opinionated about that. Today, on Windows, you can use Microsoft compiler, you can use Cygwin, you can use other MSys compiler, but and Rebar mostly say use the one you want, but it never works really. And Rebar should say at some point we are supporting this compiler and we will support it really good. There is still occasion today for Refuge. This is how we will build with Rebar the iOS and Android version, how we could integrate the toolchain with Rebar. I didn't find a solution for that. So we reworked the CouchDB base by splitting in small apps. Today, if you see the code of CouchDB, you have a big source folders in which you have some part of the code splitted, but not real Erlang apps. I mean, Erlang application that you can put in your release and let Erlang supervise them. So we split CouchDB in a lot of small applications at the beginning. We have split CouchDB in the indexers, in the view engines, the CouchDB core by itself, and on other parts. At some point, we decided that we have split a little too much because it was really difficult to still work with CouchDB code, to integrate patch, etc. So we get back and still keep the application we build, but put them in a couch code that you can find on the Refuge projects. We improve the supervision at the same time. We use a new Mochi web. By that I mean we don't start now a project. We linked a Mochi web process in CouchDB release. We don't use the string multipart API. We use the binary multipart API in CouchDB, which improved by twice the performance of the replication. We use Jiffy. We don't use eJSON, which improves also the data. We are using Lagger, not anymore the couch logs to log the things. which allows us to also log in syslogs or whatever we buy the backend for, etc. Today there's also some change in OpenSSL handlings, stuff like it. So CouchDB is that by default, so we don't see so much on that. So we have a big SSL folders with all the applications. Yes. This is CouchDB. This is CouchDB, so we have all the false application with the dependencies and a big SSL folders with all the CouchDB core insights, HTTP API, CouchView servers, etc., etc. And so we created a new core, CouchDB core, which was Rebar, and integrate 5 applications, which are Couch today, with still the HTTP parts inside, but we will remove it this weekend. Couch change, and the MapReduce server, MapReduce engines, and the replicators, which are full API with our own supervision today. And we are able to build release. So if you go on my repository, you could also find Rebar Templates, which allows you to build your own CouchDB if you want, or integrate it in your applications. So we reworked the code base, and it took us a long time to make it working really, and to have a good process to process change in CouchDB core. Patch our code with this change and continue to improve the couch base, not the couch base, but the source code base. And we started recently to buy the mesh, the Refuge Protocol by itself, which will make the decentralized platforms. So we have made some assumption. What is an identity in Couch? In Refuge, peers, which are Refuge nodes, are links with trust relationships, which means SSL certificates, X509. Each of us knows so user generate REC key pair, and the public key will be used as the identity among the peers. So key can be exchanged manually. I'll give you my key, you put it in the nodes, and the authentication will start like this, or using the social graph, which means you will be able to put your Gmail account, get your friends that are already using Refuge, getting back the identity, and putting this identity in your node and saying, I'm trusting these nodes in the networks. Or just using Twitter for that, or anything in the social graph. How we maintain groups and untrusted users. So in Refuge, you will have with the release hubs, the concept of hubs, which is basically a big Refuge node that is maintaining registered users. Registered users means if you have a lab and you want to invite some of your colleagues to share the data they have, they could exchange with this hub their keys, and the hub will play the role of a big identity server for you, and will share the identity with your nodes. And you could also have public hubs. Public hubs are something like data hubs from the Open Knowledge Foundation that are sharing data without attributions and without authentication, so you can reuse them as you want. And you have also untrusted users, so there are users in the networks, in the mesh networks, in the DHT, that you will be able to see, that will be able to take your public data, and that you will be able to use for the privacy level. You will be able to forward your query using the untrusted nodes. So everything is basically based on an SSL certificate in Refuge, and it was quite difficult to have something working with Erlang. So in Erlang, you have two modules today to manage SSL and public on the certificate. You have public key and SSL modules, the new SSL in Erlang 14. But with this module, you are not able to generate your own SSL key. Well, you can make, if you see at the test, at the source code of Erlang, you will see a file name underscore make cert.erl, which is creating a certificate for you in a full Erlang, but it has a buggy implementation of primes algorithms, which is really difficult to have. And well, why would you use that when you have OpenSSL, which is deployed in most platforms? So don't try to generate the SSL key in Erlang. I tried a lot and never had a good certificate with a good random or good seed inside. My math are not so good, but I didn't find not so much people able to do that too. So today we are just using OpenSSL. You have two ways to use OpenSSL. The one we are using currently is using a port. We just open a port to OpenSSL, create the key file, and get the key files, and we do all the rest in Erlang. Or using an Erlang driver named codebase, which is written by Andrew, where you can find on GitHub, and it will generate for you the ERISA key and export for you ERISA key records that you will be able to use with the public key API in Erlang. The public key has an ND function that you can use. You can create with a certificate, you can pass keys, and you can use it to return the public and private key used by the crypto modules. And you can use it to calculate a fingerprint exactly like in OpenBSD. A simple example, I don't know if you see the code to create a fingerprint, which is really easy. In fact, we are reading the certificate files. We get the public key from the certificate, and then just make an SHE, an hash of the digest, which is able which is possible with the Erlang API. Other things, so since we are using SSL, we need a way to authenticate the connection in Refuge with the full HTTP. So you have two ways to do that in Erlang. You could use the validate fun option in SSL modules when you start to bind your SSL sockets. You can pass a validate fun function. But this is only used to validate if the certificate is valid. If you want to build something like convergence and buy something of SSL notaries and say your certificate is valid because I have it in my database, you can use this function, which wasn't enough for us because we wanted to say to someone, you are going on this collection of data or database in CouchDB world, and say, I don't trust you, so I forbid you to read my data or to write my data. So we want to send an HTTP response back, which you can do with validate functions. So for that, we are using the peer-cert function in SSL models, which you apply on the sockets, on the connection sockets, on the client sockets, and you are able to get the peer certificate from that, and saying what you want to do. I have the certificate in my database or whatever. Soon to be released, probably this weekend or on Monday when I come back in France. There is a new model I created, which is named CouchD, SSL, which is able to do the whole authentication you have in CouchDB or in Refuge on top of HTTP API. Today, multi-web, but later in other web servers. So yeah, the other thing we'll explain later, but we are not using Erlang distribution to distribute message or to distribute data today, because we are not able today to have an easy way to use SSL sockets on top of the Erlang distribution, which could be interesting to have. So we are using HTTPS today, full HTTPS. Maybe later we will use SPD on top of that to improve the exchange. Yeah. How we discover the node? So the first thing you have to do is to exchange keys, and we have different ways to discover nodes around. We can use DNSD or Bonjour in its all names from Apple. You can use the hubs, and you can use the DHT, which is for now based on KDB protocol.
Is DNSD the same thing as Bonjour?
Yes.
And what's hubs?
The hubs are the big cluster, the big nodes, refuge nodes that collect identity for you, and on which you will connect. Yeah. Yeah. So DNSD, this is the Bonjour protocol, exactly the same. Again, Andrew have written a lot of code on that. He's also the author of the Chrome extension and Firefox extension for DNSD, and a named server like bind, but in Erlang for DNSD requests. So you can do Bonjour requests over the networks if you want. And with so we are using DNSD, which is basically a way you put your machine in your LAN, and it starts to advertise itself to the others, and you get the host and port from this machine, and start to do stuff with that. And we get a little further with DNSD. We wanted also to have a way to advertise easily our nodes to the internet. So for that, you have different ways. You can use Bonjour, and there is a protocol in DNSD that allows your application to speak with the router and open a port directly. Or you can use UPnP, which is another protocol, a SOAP protocol, which most of the router knows today, and this is a way to, this is using, this is advertising itself, not on TCP. I can't remember the name of the protocol. But this is advertising the machine by multicasting on the network, the IP and port. And it starts to discuss with the router, and the router say, I open the port for you, give me back your response if you're OK. And this is HTTP at this point, and the response comes back to the routers, and the port is opened, and you can discuss directly with the machine. But it's maybe better to speak with a demo. So you don't want to. Okay. So I will do from the start. I don't know if you see something because that's so good. So here we have the way we are building a refuge, which is just a make. We we do a make, and it creates a release here on the left. On the same time, we're starting to listen with DNSD commands, which is available on Linux or macOS this. We also open a Safari windows in which you have a possibility to see the bonjour notes, and we will try to advertise. So it binds a release, creates the certificate, the SSL certificate automatically for your release if it doesn't exist. We start nodes. Okay, so here you see nodes, and you see automatically advertised on networks, and your own nodes, and this is also automatically advertised on Safari, and you can just access to the UI and work with it. So, and with UPnP, you can also, so if you go here, this is a free box, which is a French router, and you go on that, and you see that it also open a port here for the Refuge project on which you can access from the externals. This is pretty automatic CPU activate. So in Erlang, on Erlang side, what we do is we have gen events things that gets notification from DNSD. Each time a node come up or come down, we generate an event, and we send it to the subscribers of these events or gen event handlers. Just like mostly NetAdm API in Erlang, we try to copy most of the API so we can reuse it, because DNSD is one protocol today, and we want to be able to plug any protocol we want in the future. What we can do with that automatic recognition, you can do opportunistic replication. So I have a node that I can trust that appear in my network. I can start to do something with that. I can start to replicate the letters that I had or stuff like it. I can create doc on demand eventually. I can have a multi-application interaction. This is a CouchD engines that we will build, not something that able to build HTML5 application, but something that will have internal application that you can use it, replicate it, and use it as a full application. How we do the query? We do the query by flooding nodes we know in the networks, nodes that we get via Cademelia or DNSD, and we have a content ID. Each document created in the Refuge platforms have an ID created for him, which is based on the content of the JSON, and we sign this ID with the public key of the node. So what we do basically, we have a node, first node A, which start to send the query to B and D. At this query, per node is associated an ID. The ID command B is saying to R, I have no this document. I have no document or anything that corresponds to this query. That could be a view too, or anything in the CouchDB protocols. And rather than saying to R, I have nothing, go to another node, it will start to ask to the node connected to him and say to C, do you have this data? C will answer yes. And at this point, C send back the data to B, that will send back it to A, rather than sending it directly to A. Why doing that? Because by doing that, we are keeping anonymous, mostly, the data around. So if we go over the network, you will have a 3-5 ops. You will be able to configure the ops you want to go to the C, to go to the data. And so your nodes will be anonymous. How do we choose B and D? Mostly by proximity, which is calculated by the hash on the IP and ports. And also we are randomized the query, the node we want to choose, to remove some attacks based on the position of nodes, etc. And we follow the path at any point. Other thing we do in Refuge today, you have a view change branch. So today you can have change on the document, just on document change. And a lot of people are saying it would be cool to have it on the views. I mean, an index is updated, you get the results in real time by listening it on HTTP. And you have it today on CouchDB. You can have it using on the full views or using the key on the views or start key and key. You can get in the change in the range in quite real time. So it's mostly it's working in production for some customers of me, and will be merged soon. Yeah.
Do you collapse if it's like the delete and then create entries and then just show one? Right? Like when the change comes in,
So.
The root is
Yeah, so we added a new option which is include deleted. So deleted are included in views, and the only problem is when you want to remove it, if you want to use the replication, the view change in the replication. So to do that, you have to put a document with the thing that is targeted by the view, by the emit function. So you can emit empty documents. This is the only drawbacks on that. We forked GeoCouch, which is the special level of CouchDB, written some time ago. This is now named Refuge Special. We didn't just renamed, we also adapted it to the new API of the indexing facilities in CouchDB. And we also added canon support, so you can get node by distance, get the data by distance. Chained MapReduce, this is work in progress that will be soon. It started to work. We also have distributed Couch apps that also work in production and will be released soon, open source. We want to build, because we will have nodes, we will have a network, we want also to be able to do something like Disco or Adobe. And using the node you have, the network you have, to say, I want to use these 70 nodes around, saying at some point I'm create a group, launching a task, and let them calculate the task and getting back the reduce. The result could be MapReduce, could be any pipe you want. This is something we want to work on. And that's it. You can find everything you want on refuge.io or maybe whatever. And if you have any question. So the question is if we adapt Rebar or create on the side tools to make the portable platforms, to port on the platforms. So today, what we are doing, because Refuge is working on Chiva plug on any ARM5 platforms, and it also work on iOS with a fork of some work done by CouchDB before. We have Rebar that call hooks, and these hooks say, depending on the platform, the patch set you want to use for these platforms and the chain tool you want to use. So it's working today for Mac OS X, FreeBSD, Linux platform, ARM5 platform, ARM8 platform too. iOS 2, and it's also working for Windows. David Kobler is starting to use it to port Refuge on Windows, and it started to work too. But in near future, we want to use the plugin part of Rebar and to create our own plugin to make these parts, and maybe adapt the missing parts to test for shared.
Because the nature of your project, have you thought about eventually adding a
So today it could be really feasible because you have this API that allows you to compress the data using Snappy on the disk. Today you have the SSL authentication that works on Refuge, so you can use the publish key and to encrypt the content on the disk and decrypt it when you want to index the data in the views. The tricky part is the views and the indexer, but should be really feasible today. Okay. Thank you.